Hey there. We're going to take a look at doing a bit of recursion today. And recursion, I feel like the first time you see it feels like it's really scary and that it's a little hard to wrap your head around. But I think that one of the things that helped me personally getting over the challenges that I found when I was learning how to do recursion is really having in my mind a template of how to approach any recursive problem that actually kind of works for all of them. They all have the same sort of little formula. And once you realize what that formula is and learn how to apply it, it really sort of demystifies all of the challenge that recursive programming is. So let's look at this first example. Write a recursive function to sum the digits of a positive integer. You may not use any loops. So it's a recursive function, meaning at some point the function is going to have to call itself, and the parameter is going to need to be different. One thing you got to always make sure when you're doing recursion is that when you call a function within itself, you always have some way to know for sure that you're approaching the base case. The base case being, the simplest version of the problem that could be solved directly without having to do any functions or anything. So we're going to take a look at that as we work on this problem. So open a notebook for this. Here we go. Yeah, sure. Okay, so here's my problem. Write a recursive function, sum the digits of a positive integer. May not use any loops. All right. Good stuff. So we'll write a function. Now we have to think about, so what is this function doing? It's going to sum the digits of a positive integer, so clearly it needs to return an integer, int. And we'll call it sum digits, because it's going to sum the digits, and it's going to take an integer. All right, makes sense? Okay, now, before I even figure out how I'm going to actually solve this problem, anytime you have to do any recursive function, the very first thing you should do is think about what is the base case. What's the easiest form of this problem to solve? And when I think about it, these integers might have a ton of digits, or the simplest is they just have one digit. So the base case here is that we don't have to do any function calls, anything fancy. If we know that the integer is only one digit, then the sum of those digits is itself, which is pretty straightforward. So if my integer is less than 10, remember it says positive integer, so we know for sure it's not going to be negative and it's not going to be 0 or anything like that. Then I only have to worry about 0 to 9, which are digits of numbers. If my integer is less than 10, then I can just return my integer. Boom. Seems really easy, right? Now the second part of trying to solve one of these recursive problems is thinking about the recursive steps. So you need to, at this point, kind of have faith in yourself and really believe that your function, once you are done with it, is going to work. And once you've kind of grasped that concept in your mind, the rest of this actually becomes a lot easier if you have the presumed assumption that your sum digits code, once it's finished, always does the thing it's supposed to do. And if that's the case, you can now rely on this, because the sum of the digits of a positive integer, let's say that I have 2, 3, 4. It's 2 plus 3 plus 4, which is that 9, right? But how do we break this problem down? And when we're working with any kind of recursive code, we're trying to take whatever the input is and shrink it every time. Well, the solution to the sum of 2, 3, and 4 is the same thing as the solution to, I guess there's a couple ways that I can look at this. I'm just trying to think ahead of how I'm going to solve the problem. Now, when I add 2, 3, and 4, I can do it in any order. I could do 2 and 3, then add 4, or I can do 3 and 4, and then add 2. It doesn't really matter. But in any case, what I actually want to do is just grab one of these digits and take that value, and then I can worry about all the rest of them. I think what we're going to do is we're going to go with actually this one, which is it's the sum of 2 and 3 plus 4. Now, if I have 234, how do I get the 4 out of it? And if you think way back to when we were talking about operators, there's a really handy operator that will help us do that, and that is, of course, modulo. So the last digit is my integer mod 10, right? So the So let's say that we were doing 2, 3, 4. Now the last digit is 4. Now I want to return the sum of all the digits in my number. So actually, I only need one more line. I'm going to take my last digit and add the sum of all the other digits that are left. Now, what are all the other digits that are left? Well, if it's 234, then it's 23. How do I get from 234 to 23? I just divide by 10. Integer divided by 10. Sum digits, 234 is 9. Sum digits, 1, 2, 3, 4, 5 is 15. And look at that. This seems like it's like kind of magic, right? Look how few lines I had to write to get this working. But really the reason that this ends up not being so difficult is because I've already assumed in my head that when I write some digits right here, it's going to do what it's supposed to do. And since I have that confidence, when I write this last line, it seems like it's kind of magical. Like, how the heck does this actually do what it's supposed to do? But the reason it does is because some digits, assuming I've done it correctly, adds the digits of the positive integer. Even though when I was typing this, I hadn't finished the code, if I believe that when my code is done, it will work, then at the point that I'm actually running this, I can use that assumption to make the problem a little bit simpler. In this case, how do I simplify the problem? Well, once I know what the last digit is, which is 4, for example, or 5 over here, then I've changed what the problem is. I'm no longer trying to sum all the digits. I'm trying to sum the rest of the digits plus the one that I've figured out. I figured out the last digit is 4 or 5. I don't need to do any more math with that. So I know that this is the last digit, and all I need to do now is sum the rest of them. So I need to sum 23 or 1, 2, 3, 4. Well, how do I do those? Well, now we now we can start thinking about it in terms of repetition. So when we run sum digits of my integer divided by 10, my integer was 234. When I divide by 10, it uses integer division, so it cuts off the, so instead of giving me 23.4, it gives me 23. Then with 23, I'm now kind of back to the start, right? Well, 23 is not a single digit, so I keep going. The last digit of 23 is 3, and now I'm adding 3 and the sum of all the other digits. What are all the other digits? 2. So when I get here, now I go to my base case, and that's why it's super important to have the base case or this will never stop. But the base case here, when I have 2, well, 2 is less than 10. So the sum of the digits of 2 is 2, which is not too hard. And now I kind of go backwards, right? So I return to where originally I was, which is adding 3 plus 2, and I return 5. Where do I return 5 to? The previous time I was making my sum digits work, which is when I had 23, the sum of 23 plus 4. And since this sum calculated as 5, I just add 4 and 5 and I get 9. If you want to see this working step by step, which I really recommend that you do if you want to get it working correctly, you really should consider running it through Python Tutor so you can kind of see each step one at a time. So here if I do sum digits of 1, 2, 3, 4, 5, you can actually see it go through one step at a time. So the first time I go to sum digits, it's 1, 2, 3, 4, 5, and the last digit is 5. The next time it's 1, 2, 3, 4, 1, 2, 3, 1, 2, and 1. And the sum of the digits that are 1 is 1. So that is what's returned. And I return that back here. The sum of those digits is, I guess I should have an output here, huh? Hopefully you can follow along. The sum of 1 and 2 is 3, so I just add 2 in the 1 that I got, and then I add those, and I add those, and I'm basically just consolidating everything together until I am finished. So I definitely recommend when you do these recursive problems, if you're not really comfortable with how everything works just yet, try running it through the Python Tutor. Maybe take what's here actually and add some code so that you can, this is exercise 1, add some code so you can see what the values of some of these things are. What's the value of this? You don't have to write it in this line. You can make another variable called int recursive call equals sum digits, my integer over 10. And then you can actually see what the numbers are, and that might be helpful too. Okay. Moving on. Write a recursive function repeat that prints out the string s a total of t times. I mean, not use any loops. Okay, so same kind of approach. Your notebook, C++. This is exercise 2. Here's our problem. Okay. So, gave us already the name of it. Now, print stuff out doesn't seem to say it returns anything at all, so this must be a void function. And now to think about the base case. So, what's the simplest way that this function could work? Well, it has to print out a string a total of t times. Well, if t is 1, it seems pretty simple, then I print it out. And that's about it. Actually, no, even simpler than that. If t is 0, I don't print anything. So my base case here actually is going to be if t is 0, then I'm done. Otherwise, now I need to actually, print something out. So I will print out, and I guess I'll need to have all of the little libraries and things. Now, I'm going to print out the string. Okay, so I printed it once. So let's suppose t is 1, for example, or maybe even higher. Let's suppose I want to print this out 10 times, right? So t is 10. Now, I've printed it out once, and I need to print it out 9 more times. Well, if I can't use a loop to run 9 more times to print it out 9 times, what can I do? Well, I have a function right in front of me that's going to print something out a total number of times. So now I just need to repeat same string, and instead of t times, I just have t minus 1. Repeat, I guess I'll make a variable, string, my name is Michael. Repeat, my name, say 5 times. There it is, that's it. So this is kind of I would say this is maybe even simpler than the other one, where there's really only the base case, there's what you do when it's not the base case, and then your recursive call, keeping in mind that you always want to make sure that you are approaching the base case, finding some way to get closer to when you stop. In this case, I'm assuming that t is going to be non-negative. If t is negative, this whole thing is going to fall apart, so to be careful about that. Maybe I actually want this to be less than or equal, just in case. But if t is a positive number, say 5, then this base case won't matter for a while, but I'm going to print it out. I'm going to repeat, t will be 4. Print it out, repeat, t will be 3, print it out, and so on until finally I try to repeat when t is 0. And if I'm supposed to repeat this 0 times, that means I'm done. I don't want to be printing anything anymore. And when I return, I kind of go back to the previous function, but as you can see here, after I run repeat, nothing happens. We're just done. The function finishes. So all of them just finish, and that's it. The program's done. No infinite loops or anything like that, and it does exactly what I want. Okay, last one. Write a recursive function that performs a linear search. You may not use any loops. Okay, so this one's a little bit more involved, for sure, but it shouldn't be too bad. Okay, descriptions for this aren't super specific, so I'll make a few assumptions here. Okay, so I want to do a linear search, meaning I want to find presumably the index of the target or -1 otherwise. So if the thing I'm looking for is in my my array, I suppose, then I will return the index of that element, and if I don't find it, then I'll return -1. So I obviously want to return an index. It's going to be an integer. It's going to be a linear search. What are my parameters? Well, I definitely need an array that I'm working with. Maybe I'll just have a pointer to that array. So here also doesn't specify what the type is. So we'll go with integers for now. Keeps it simple. So this is my array. And I have a target. And now I have to think a little bit about how I'm going to be approaching this problem. So when I'm doing a linear search, what am I doing? Let's say I have, for instance, my array is 1, 2, 3, 4, 5, and I'm trying to look for 3. If I was doing it with a loop, I would look at 1, then 2, then 3, then 4, then 5, which is not a bad approach. Maybe I want to do kind of the same thing here. If that's the case, here's what I need. I'm going to need to have kind of two options. One option is after I look at the 1, I then try to do a linear search on 2, 3, 4, 5, because I found that 1's not there, right? But here's the issue: is that means now I'm going to need to allocate memory for a new array every time I do a recursive call, and that sounds like it's going to take up a lot of space in the computer. That's not really great. So what I'm thinking I might do instead is just indicate which is the most recent one that I've checked. Which element am I supposed to be looking at next? And if I have, and when I'm doing my recursive search, all I actually do is just check to see if that one is what I'm looking for. And if it's not, then I continue on my way, kind of like with a loop. So here's what I mean by that. So I'm going to add a third parameter because it doesn't say I can't. So it'll be int index. And so when I call my linear search, the first time I'm going to call it, I'm going to pass it a pointer to my array. I'll pass it the thing that I'm looking for, and I'll pass it 0 because I want to start from the beginning. Now, if my array of the index is the target, if I basically have found what I'm looking for in the first time that I run this, maybe it's the first element, then I just return my index. Boom, great. Base case, easy, pretty simple. Let's just return 0 for the moment. Sorry, return -1 because this means I didn't find it, right? Now, this isn't going to obviously work for most things, but let's suppose that I have int my array is new int 5 plus my array I is I times 10. Oh, sorry, at my array. Oh, actually, I think this is fine. Yeah, I think this is okay. So my array now is a pointer. It's going to point to an array that has 5 numbers, 0, 10, 20, 30, and 40. I think that seems all right. Now let's say that I want to go and do a linear search to find 0, that's the first number, in my array. This is my array. I'm looking for 0, and I want to start at the beginning. Yeah. Right, it's in index 0. And what if I start at the end of the array? Am I going to find it? No, I'm not. Now, what is this doing? Basically, right now, because I haven't finished, given the pointer to an array of numbers, given the thing that I'm looking for, and starting from whatever my starting position is that the one I'm looking for? Great. If so, you found it. And otherwise, I've returned -1 because I haven't done the recursive step yet. But at least I know for sure the code here compiles, at least. And now we can start worrying about, okay, how do we actually find what we're looking for? Well, if the index that we're looking at doesn't match the target that we're trying to find, well, I guess we'll just change our index, right? So we can do, oh, another thing is, I forgot, we actually need one more parameter, which is the size. The size of our array is 5. This is important because if you don't actually have the size, then that could be an issue. Okay. Now, there's actually, I suppose, 2 base cases when you think about it. One base case is we found what we're looking for. The other base case is that we've gone through the whole array and we haven't found what we're looking for, so that we return -1. So actually, I can say else if index is equal to size minus 1. Actually, what we'll do is, so I'm going to change the order a little bit. If I found it, great. If I didn't find it, we're going to boost up the index plus plus. So we're moving on to the next number. Now, if the index is equal to the size, that means I've gone through the whole thing and I haven't found anything. Now I'll return minus 1. Otherwise, I will, so my base case here is it's what I'm looking at. Great, I found it. My second base case is it's not there, return minus 1. My third option is I actually have to do recursion. In this case, supposing my linear search works correctly, I will return its result, so do a linear search. I'm still passing it my array, I'm still passing it the target, I'm still passing it the same size, and I'm still passing it the index. However, note that right now, this index isn't the same as what this was when it started because I increased it by 1, which means that eventually my index is either going to reach the size and stop, or it is going to find the thing I'm looking at. And let's try a couple cases so we can see. So, restart. Oh, what did I mess up here? Expected expression. Is it elif? No, it's Python. Should be else if. I did something stupid, I bet. Let me see here. Expected expression. Oh, I see what it is. This shouldn't be an else if, it's just if. I'm thinking this or this, but realistically, if this is false, then everything else is after here is going to run anyway. My mistake. Okay. It's a very silly mistake to make on my part, but not a matter. Okay. Let's change this test up a little bit, because right now it's got a lot of zeros and it's not really easy to follow. So, let's just output the values of my array, just so we can see it. My array I. Okay, so my array contains 0, 10, 20, 30, 40. So if I'm looking for 40 in my array of 5 numbers, starting from position 0, then I will find it in position 4. Boom, there we go. Again, this is one where I really recommend you try to take a look at how this is actually operating in something like Python Tutor, because that will make it a lot clearer about how this thing is actually working step by step. And you could even consider, instead of using the index, actually use a pointer. And you can have your pointer increment instead of having your index go up. That's another option, I suppose, to get this to work. Up to you to how you implement it, but I think the key thing here is that this time we actually do have 2 base cases, because there's 2 ways that this could go without you having to do any kind of recursion. And only in the third scenario, where you didn't find what you're looking for and you still have more numbers to go, do you do the linear search. And at no point here did I have to write a loop. It wasn't necessary. So probably not very common that you would do a linear search using recursion, but it is important that you know how to do it, because it really gets to the fundamentals of what is recursion, how does it work, and how do you make something like this for any kind of iterative problem. And you can. If you're looking for more practice, I definitely recommend actually going back to when we learned loops and try to redo as many as you can of the loops that we've done with a recursive approach instead. And that will maybe give you a chance to practice this if it's something that you're still feeling uncomfortable with. So good luck with your recursion, and I'll see you in class. Bye-bye.